Let's look at compound interest a little bit further. Let's say I started with investing $5,000 at 5% annual interest, and it's compounded monthly. What compounded means is that that's when they calculate your interest. So if 5% is the annual interest rate and they're calculating it monthly, let's think how that will happen. Okay, so to find my balance, let's say amount in 5 years. We're just going with a whole bunch of fives, aren't we? Amount in 5 years. Okay, so amount, we have our initial investment, and I'm just going to use this example and then we'll write down the formula in a minute. So our initial amount, then we need to figure out what we're going to be multiplying by each time. Well, we have our original amount, so that's a 1, plus that interest that we're gaining, because it's an account where we're going up. That's 5% annually, but we're compounding monthly. That means that 5% is getting divided up over 12 months. So 0.05 divided up in 12 months. Now, up here, we need to know how many times this is going to be calculated. Well, it's being calculated 12 times a year for 5 years. So how many total times is it being calculated? Well, that's 12 times 5. That's 60. So 5,000 times 1 plus 0.05 divided by 12 to the 60th. That gives us our account balance after 5 years. 5,000, 1 plus 0.05 divided by 12 to the 12 times 5, or I can go ahead and write it as 60, and it gives me my balance. Now that's the balance in the account. How much interest has been earned? Ooh, interest earned. That's my total account balance. And I started with $5,000. What have I earned? Well, that would be $1,416.79. Just wanted to tack that on there. Okay, so let's think about what we did here. We found our account balance by starting with our initial value. In finance, that is called the principal. We found it by whoops, I was supposed to see 1 plus that interest rate divided by the number of compounds in a year. We had to split up that interest rate. And then we took those number of compounds times the number of years. So N is the number of compounds. And then T is the number of years. And R is your interest rate. So let's see, what if we had, and the bell's fixing to ring, so hold on just a second. Okay, so let's try another one. Let's go with $3,000 at 4% interest. And let's do compounded quarterly. So how many times a year would that be? That would be 4. So that means our number of compounds is 4. Our rate is 4%, so it's going to be 0.04. And let's say we want to know how much is in the account, how much after, let's say 7 years. So our account balance is equal to the principal, which means how much we started with, times 1 plus the interest divided by the number of times we compounded, 2, the number of compounds times the number of years, because we want to know how many times total it's being compounded. So, let's see. That would be 3,000 times 1 plus 0.04 divided by 4 to the, and you could actually type 4 times 7 in here, and that would give you your account balance. Now, what if I asked a different question? Let's say we still have $3,000 at 4% interest compounded quarterly, but I wanted to know, instead of what the balance is, I want to know when the account doubles. I really want $6,000 in my account. I don't want just the $3,000. So I want to know when the account doubles. We know we want the account to be $6,000. We're still starting off with $3,000. Has the interest rate changed? No. It's still compounded quarterly. So the number of times a year times the number of years. The number of years is the part that I don't know. So let's see how we would solve this one. Notice the variable is in the exponent. So I need to get this by itself first. So let's divide both sides by 3,000. That's going to be 1. Actually, I could write that as 1 plus 0.01 to the 4t. That's really 1.01. Now, remember, the variable's in the exponent, and I want to get it out. So we can rewrite this as a logarithm. The base is 1.01. The argument would be the 2 equals the exponent. So I need to figure out what this is and then divide that by 4. Remember, there's 2 ways to do that. You could do log of 2 divided by log of 1.01. Or, if you have one of these fancy calculators, alpha F2, log base is the 5th option. Log base 1.01, 2, gives me the same answer. So that's what this logarithm would be. And to find out the actual number of years, we're going to divide by 4. And so our time would be 17.4. So that's 17 years. That takes a long time.